So now it's time to start talking about absolute value. And we're going to look at it and understand what it means with the aid of our calculator. So bring the calculator back up. So I'm going to ask my calculator to graph for me the absolute value of x. Now, the absolute value, the notation for that is ABS. Any special notation on the calculator is found in what we call the catalog, right down here. Okay. Now the catalog, right now the catalog is listing things alphabetically. So the alpha key is pretty much in lock when you're on the catalog, and ABS is the first item in the catalog. So I'm going to ask to go and have the graph of the absolute value of x expressed for me. And here it is. Okay, and of course it just writes it in the what's called the pretty print, which is correct mathematical notation. Let's look at the picture. So again, second graph. All right, there's the absolute value of x. Segments, or should we say rays, that divide quadrant 1 and quadrant 2. There's a 45-degree angle there. You know, makes sense. If I'm asking this to graph y is the absolute value of x, if I give it 3, it gives me back 3. If I give it -5, it gives me back +5. So that's pretty convincing. Here's something that isn't always as convincing, so that's why we want to define it. Okay? So the absolute value of x is defined in the following way, and you got to understand this as the basis for all the problems we're going to do. It's actually defined as a piecewise function. It is defined as x, or as the opposite of x, or as 0. Now, the important thing is you realize that this reads the opposite of x. And if you read that as negative x, then you'll never understand it. This reads the opposite of x. So, when is the effect of the absolute value on a number effectively no effect? Well, if the number's positive, right? If you have a 5, take the absolute value of 5 is 5. The absolute value of 72 is 72. So, if x is positive, then the absolute value of x is x. In other words, it has no effect at all. Okay? Now, what if we're taking the absolute value of 0? Well, it comes back to 0. So if x is equal to 0, then the absolute value of x is equal to 0. Okay? Now, this says, when is the operation known as the absolute value give back the opposite of what you give it? And again, it's important that you read that. So if I say, okay, the absolute value of -5, well, that's equal to 5, right? We gave it a number and it gave back its opposite. The absolute value of -27 equals 27. We gave it a number and it gave back the opposite. So any negative that we give it, what the absolute value does is turn it into its opposite. So the statement up here is completed when we say if x is less than 0. If x is less than 0, then the absolute value of x is equal to opposite of x. Yeah, absolute value of -27 is 27. When you give an absolute value a negative, it turns it to its opposite. All right, now let's look at that from the graphical standpoint. All right, and try to defend that. Let's pull the calculator back up. All right, here is the graph. All x's are positive in quadrants 1 and 4. The graph of the absolute value for that is the graph of y equals x. When x is, okay, when the x's that you are giving are negative, it produces positive values, but the graph of this line itself is the graph of y equals negative, the opposite of x. Let's defend that, okay? So I'm going to go here. I'm going to graph, I'm going to turn off, you'll remember what the graph of the absolute value looks like. It's that V shape. I'm going to turn it off for now, and I'm going to graph in y2 x, just y equals x, okay? No surprise, we know what y equals x equals. Well, y equals x looks like half of the absolute value of x, right? Okay? What about the other half of the absolute value? Well, key it in. Here's where you got to be careful. The calculators are designed to have a distinction between the subtraction sign here and the opposite sign. So the negative sign in parentheses is the opposite sign. Here is subtraction. If I key in that here, it's going to give me an error because, again, there's two different keys. So be mindful of that. Okay, so we're going to get out of that. We're going to correct that, clear it, and we're going to use the opposite key. There it is. Okay, so put them together. Of course, the graph looks like an X, but we're only looking at half of this line, which is y equals negative x. That is y equals negative x. This is y equals positive x. If we could erase these halves, then that would be the absolute value of x. Well, we can actually erase the those halves. So let's go back and look at this. Okay, I'm going to, for the time being, turn this off. I'm going to turn that back on, remembering that's just a graph there, y equals x. Okay, now if I say y equals x and I put a condition, in other words, I want to say y equals x only when x is greater than 0. Only when x is greater than 0. So that's in condition. So come down here. The condition if is actually entered after the x with this symbol here, this straight line. So I'm going to click on that, and then I'm going to put the condition x is greater than 0. Okay, where's our greater than symbol? Okay, we have a greater than symbol somewhere on here, I know. Okay, yeah, we're back. I had to find that greater than symbols. Of course, they're right down here. Here's the greater than symbol. It's the secondary key. So, so second dot greater than 0. Okay, enter. Now that will graph for me effectively what we call the half line. It's only graphing. Okay, it's actually graphing this condition. It's graphing the line y equals x only when x is greater than 0. So therefore, it's satisfying this condition, which is, as you can see, half the absolute value graph. All right. Now let's see the other half. So let's go back to y equals. Here, let's turn this on at 4. Come back. Let's turn this one off. So this is y equals negative x, and we're going to put that condition again, the condition right here, as stated, with x less than 0, right? Less than 0. So second 0, 0. Okay, and that condition has been applied. And looking at that, what we have is effectively the other half of the absolute value graph. All right, if we come back and we put them together, turn them both on, looking at them together, there is the graph of the absolute value. And just to prove that that is the graph of the absolute value, we'll graph the absolute value, which will simply superimpose on the existing graph, showing no difference. And there you have it, a defense, a graphical defense of the definition of the absolute value of x being defined as the absolute value of x is defined as x whenever the values inside are greater than 0, as 0 whenever the value inside is 0, and as the opposite of x whenever the x value that is inside the absolute value is less than 0. That's the definition of absolute value.